learners, my subscribers and my viewers, welcome to this channel at Source Academic Online Class. So today we are going to be seeing a question under motion, which is VT graph, velocity time graph. So JAMB 2012, question number 5. So let me quickly explain the definition of what velocity time graph. What do we mean by velocity time graph? The word graph means graphical representation of the what? Of the velocity of an object moving in vertical axis with respect to time taken on the horizontal axis. Hope I'm communicating. So when you see this diagram, it shows how a velocity of the body moves. That it moves in between the vertical axis and the horizontal axis. Although always know that the vertical axis is what will carry the v, velocity of that object, while the horizontal axis is the what? The time taken for that object to move uniformly. There's some case it moves non-uniformly, but today we are going to be seeing something under uniform what? Motion. How together? So note, they can ask to calculate so many things. So I will use this explanation. We will use that to answer which one is the best answer to pick, which one is the correct answer here. So we have two things. So we have so many things that we can calculate here. We can ask to calculate the total distance covered by the object. We can calculate the acceleration of the object. We can calculate the what? The deceleration of the object. What do we mean by the acceleration? Deceleration, total distance covered. Are we together? And each area of that of different shape here. So let me use. Note that when dealing with, we have two slopes as far as velocity time graph is concerned. What are the slopes? Well, I can have vertical axis like this. Are we? Whereas I have an object accelerating like this. When you see that the object, is different from this shape. When an object starts from this zero region and is accelerating, the velocity increases. And the what? With respect to time, this is the time. We have already said that these are the time. So it increases with respect to time taken on the vertical axis. So this, we call this what? Accelerating or acceleration of an object. Are we together? The next thing we have, when it reaches here, it can move like this. We call it uniform velocity. Uniform what? Velocity. Then the body can later come to rest like this. We call it what? Deceleration. Deceleration. Are we together? So now note, we have, when you are dealing with, if you have to calculate slope, we have only just two slopes here. So it's either you calculate slope for this acceleration of the body, or you calculate slope for this what? Deceleration of the body. Acceleration means when how the velocity increases with respect to time, while deceleration means how the body comes to rest, the velocity decreases with respect to time as well. So that is deceleration. Inverse of acceleration. That this one is constant velocity, or uniform what? Velocity. So it has this one, it becomes static. When the object is moving in a straight pattern like this, the velocity remains the same. If it is 20 here, 20 here, 20 that is here is also the 20 that is here before coming down to rest. So when you say 20 minus 20 becomes 0, 0 divided by t becomes nothing. So no acceleration is here, acceleration is here, deceleration is there, negative form of acceleration. Are we together? So this is how the shape is. And note that, let's use that to answer this. We can have different shape here. In our next video, I'll be telling you what are the shapes that we can see here. We can see right angle triangle here. We can see, if I break this one, we can see another section here, which is rectangle. We can see another section here, which is also right angle triangle. We have two right angle triangle, then we have the what? Rectangle. Are we together? So in our next video, I'll be telling you how to solve this. But let's come to this. That means we only have acceleration when the body moves like this. So when this is cancelled, let's compare it with this diagram here. When it's cancelled, we have only this one. And this one now, do we have anything like acceleration here? No. We only have uniform what? Velocity or constant velocity. Are we? So note that always when a body accelerate, is either it move like this, Are we together? When you don't see it like this, you can also see it from the zero origin like this. But when you see it like this, that means there is no acceleration there. So let's use that to answer this question. This one now, and let's compare it with this one. Are they the same thing? They are not. This is acceleration, uniform velocity. This is deceleration. Are we together? So let's come to this. This is what we are given. So inshallah, in our next video, I'll be telling you how to solve it. All related questions regarding this VT graph. From the velocity time graph, show above which of the following quantity cannot be determined. Which of the following quantity cannot be determined in as far as this graph is concerned? A, deceleration. Can we see deceleration here? Yeah. When this is uniform velocity and compared to this deceleration, so we can see this shape is the same thing as this. A body coming to an rest, we call it what? Deceleration. Are we together? We can determine that. What follow? Initial velocity. Yeah, we can see initial velocity. A body will start from zero origin. Before moving to this, before coming to this, there will always be a what? Initial velocity. Are we together? So the initial velocity, this is the zero origin before the final velocity. Then before coming to this will also be our initial velocity. When coming to rest, we call this initial velocity. We can also see that from this diagram. What again? Total distance traveled. Yeah, we can also see that. I mentioned that when we calculate this shape and this shape and this shape, then we add them together, it becomes total distance traveled. So we can also do the same here. How many shapes are we having? We are having rectangle. So now, welcome back. So if you are finding this video very helpful, don't forget to like, share, and also what? Subscribe. And you can DM us on our comment box section for more questions regarding this. How together, I still remain your humble self. So let's try and finish the whole thing. So don't see this question as a bulky question. It is not bulky. It has to do with what? Just a trick. That's what they need here. Are we together? We are just comparing shape. So now let's move to total distance traveled. Yeah, we can see one section here, another section here. So when this is rectangle, this is right angle, triangle. When I calculated this and I calculated this, so I can add them together. So from this diagram, total distance covered can be found here. Can be found here. Are we together? Then initial acceleration. The question comes: which one will be? Which of the following quantity cannot be determined in this, as far as this graph is concerned? I know by now, based on what I've just explained here, you will know that what will be the answer. D should be the answer. Initial acceleration. But there is anything like acceleration here. Because I told you that for a body to accelerate, it must move like this. Then we can get an acceleration. Or something of this. This is also an acceleration. But check this diagram. Is there something of this there? No. So we can't. The following quantity cannot. The quantity that cannot be determined here is initial acceleration. Nothing like acceleration here. We only have deceleration. We only have this one. Well, let's compare it with this one. We only have uniform what? Velocity. Nothing like acceleration. Check this and check this. They are different things entirely. So the answer, the one that cannot be found there, is this initial acceleration. Nothing like final acceleration here. Nothing like a calculation regarding acceleration here. And I told you we have how many slopes? We have two slopes. We have this one can be our first slope, and this one can also be our second slope. So inshallah, when next we meet, we are going to be solving this. How can we solve the total distance traveled? How can we solve the deceleration of this body? And so on and so forth. Subhana rabbika alhamdulillah shada la ilaha illa anta astaghfiruka wa atubu ilayk. So this is the correct answer. Answer D, option D is the correct answer. Please, if you are finding it very